We're going to be focusing on accuracy versus precision. The accuracy of a measurement is how close the measurements are to the real or accepted value. The precision of a measurement is how close those collected measurements are to each other. You can see over here we use like a target analogy just to make this a little bit more visual. If you have measurements in the lab that are all over the place and none of them are close to what the real answer should be, that's kind of what this target represents. Low accuracy, low precision. But sometimes we can get measurements that are very close to each other. They might be way off target or very far from the average. High precision, low accuracy. Sometimes there is a little bit of natural variance in our data. It might be a little bit far off the mark, but if it's close to what it should be, that could be a high accuracy data set with low precision. The last situation that we can find ourselves in is the most ideal. We want all of our measurements hopefully to be very close to each other, high precision, and close to what it should be, high accuracy. There's two types of errors that can introduce variance in our data, random errors and systematic errors. Random errors are caused by unknown and unpredictable changes in the tool or in the environmental conditions. Systematic errors are things that we can control a little bit more because it can be caused by specific device malfunctions or actual mistakes in our procedure. A random error can be something like we measure something on a balance and that balance is affected by static electricity and it causes the last number to move back and forth a few times. Systematic error is something that we can actually fix. The balance was calibrated incorrectly and inconsistently reads 5 grams more than the mass that is actually present. That's something that we can fix and that's something that we can control. I have 3 data sets here. A laboratory setup is designed to maintain a temperature of exactly 38.0 degrees Celsius, and 3 different students calibrate the heating lamp, and the temperatures are collected here. So take a moment, pause the video, and I want you to take a look and see if you can identify the level of accuracy and precision, high or low, in each of these data sets. Student 1's information is all over the place. The precision is obviously very poor. You even take the average of these numbers, you average these 5 numbers, it comes out to be more than 39 degrees Celsius, which is a full degree off of our mark. So I would say this is poor accuracy and poor precision. This second set has measurements that do vary a little bit. The variance is within a degree. I would say that these numbers are fairly precise. And if you take the average of all of these numbers, we get a number that's very close to 38 degrees. So I would say that is high accuracy as well. The precision of this third student is the highest of any of these groups. However, it seems as though that thermometer was probably calibrated incorrectly. There seems to be something that is skewing the data towards 49 degrees. So that is probably the result of a systematic error. A mathematical way for us to evaluate the level of accuracy of a given value is its percent error. The percent error of a measurement is given by the absolute value of the difference between the value of what is collected versus what is accepted, divided by what the value should have been, or the accepted value, times the number 102 converted then from a decimal into a percentage. You are expected to know how to use this equation to calculate percent error. So your last task is to use these 3 problems to practice using the percent error equation. The answers are listed below. So I would spend some time and make sure that you can calculate percent error given the information in these 3 problems.